Section 6.3, Trigonometric Functions of Angles. For the most part, this section is already stuff that we've gone over. It's either now just with degrees instead of radians, or it just generalizes some things that we already talked about. So first of all, we're going to generalize things and talk about any angle in standard position. So that means it's coming out of the origin and you start measuring at the positive x-axis. But the radius can be anything, not just one like we did for the unit circle. So then the radius is the square root of x squared plus y squared, which is just the Pythagorean theorem, so that kind of makes sense. Sine is y over r, it's the y coordinate over the radius. Cosine would be the x coordinate over the radius. Before we just talked about them as x and y coordinates, now it's over the radius. Tangent still be y over x. And cosecant, secant, and cotangent are still the reciprocals. So now let's look at an example where we figure out cosine of 135. So first, if you think about the unit circle, 135 degrees would put us over here, which will be the same thing as 3 pi over 4, if you remember from the unit circle, which is the point negative square root of 2 over 2 square root of 2 over 2. Since it's cosine comma sine, cosine would be negative square root of 2 over 2. You can also use the all students take calculus, and since that's in quadrant 2, only sine is positive, which means cosine is negative. Next, let's look at 390, tangent of 390. So if you were to graph that, it goes all the way around the circle, and then that'll be 360, so that'd be 30 more degrees, which would match up pi over 6, which is square root of 3 over 2, 1 over 2. Since we're doing tangent, that's sine over cosine. So that's going to be 1 over the square root of 3, which you should write as square root of 3 over 3. Just like with radians, you can use reference angles, which would just be the angle between the terminal side where it stops and the x-axis. So for 5 pi over 3, that's almost 6 pi over 3, which would be a full circle. So that would be down in quadrant 4, but the reference angle will be just pi over 3. For 870 degrees, you can subtract 360 from it, just like you could subtract 2 pi from radians. So that'll be 510. Since that's still bigger than 360, you can subtract it again. So that'll be 150. Then for your reference angle, it's just asking how far away from the x-axis. So how far away from 180 degrees? It's only 30 degrees away. You can always just do 180 minus whatever you have. So our reference angle just be 30 degrees. It would be 30 degrees above the negative x-axis in quadrant 2. So now we're going to use those reference angles and find sine of 240 and then cotangent of 495. So first we need a reference angle, so how far from 180 is that? That's 60, so we can use 60 as our reference angle. $60 degrees would be like folding down our pointer finger. So that means at that point will be 1 over 2 square root of 3 over 2. Since it's sine, it's going to be square root of 3 over 2. And since it's 240 degrees, that means that it's going to be in quadrant 3, because it would be 180 plus 60 more. So if we use that with our all students take calculus, tangent is the only thing that's positive, which means sine is negative. So sine of 240 is negative square root of 3 over 2. Now 495 degrees, that's going to be more than one full circle, so let's first subtract 360. It's 135. Then you can subtract 180, or flip it, it doesn't do 180 minus 135. Either way, the part that matters is 45 degrees. That's our reference angle. Since it was only 135 degrees, that means it's 45 degrees above 180, before 180, so it's over here in quadrant 2. Again, we'll use all students take calculus. Sine is positive only, so that means cotangent is negative. And cotangent will be cosine over sine. And since that's 45 degrees, that would be like folding down your ring finger. So it'd be 2 over 2, or just 1. And since it's in quadrant 2, it is negative. So it equals negative 1. Find sine of 16 pi over 3. Since it's over 3, we know that that's the important part for our reference angle. But 16 pi over 3. For every 6 pi over 3, which would be 2 pi, it goes around the circle once. So it'd be 6 and then 12. So that's 4 pi over 3. So if you think about that on a unit circle, it goes around once, twice, and then 4 pi over 3. So it goes halfway and then 1/3 more. So we are in quadrant 3, but the reference angle will be pi over 3 because it's pi over 3 below the x-axis. And then since it's in quadrant 3, all students take calculus. Tangent's the only positive, which means this is going to be negative, since it's sine. And then pi over 3. Fold down your pointer finger. So sine is square root of 3 over 2. Since it's negative, it's negative square root of 3 over 2. For part B, negative pi over 4. that'll be negative pi over 4, so we're going clockwise pi over 4 degrees, or radians, so it would be like 45 degrees. And we're looking for secant, which is the reciprocal of cosine. So let's first find cosine. Reference angle will be pi over 4. So you'd fold down your middle finger. Cosine would be square root of 2 over 2. But since it is secant, it's the reciprocal of that. So it's 2 over square root of 2. Not supposed to have square roots in the bottom. So you get 2 square root of 2 over 2, which simplifies to just a square root of 2. Since it's in quadrant 4, usually all students take calculus. Cosine is positive, which means secant will be positive, so it's just a positive square root of 2. So here we just have a review of the identities that we've learned already. The Pythagorean identities, and these are just basically the definitions of cosecant, secant, cotangent, that sort of thing. So first we're going to try to express sine in terms of cosine. So all that really means is we're going to take one of these, we want to take one of these expressions that has sine and cosine in it and solve it for sine. So we'll take the Pythagorean identity, the first one. Sine squared plus cosine squared equals 1. Subtract cosine squared over. So you get 1 minus cosine squared. And then to get rid of the squared on sine, square root both sides. Don't forget plus or minus. So if it's in sine equals square root of 1 minus cosine squared. So if you think about the quadrants, all students take calculus, so sine is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. So you could say in quadrants 1 and 2, sine equals positive square root of 1 minus cosine squared. And then in quadrants 3 and 4, sine would be negative, so sine is negative square root of 1 minus cosine squared. For part B, we're trying to express tangent in terms of sine. So we can start with tangent is sine over cosine. And then we don't want cosine, we only want sine in there, so we're going to have to take the same Pythagorean identity. And this time we want to solve for cosine so we can replace it. So that means cosine, basically doing the same thing we did in the previous example, is plus or minus the square root of 1 minus sine. And again, going back to all students take calculus, cosine is positive in quadrants 1 and 4, and negative in quadrants 2 and 3. And then since the example says in quadrant 2, we're looking at the negative in quadrant 2. So in quadrant 2, tangent equals sine over the negative square root of 1 minus sine squared. For another example here, we have secant equals 2, and our angles in quadrant 4. So our angle is down here. All students take calculus, so only cosine is positive over here, which means secant is positive, which makes sense. So if secant is 2, that means cosine will be the reciprocal, 1 over 2. And we know that sine squared plus cosine squared equals 1. If cosine is 1/2, then cosine squared is 1/2 times 1/2, which is 1/4. Which means sine squared equals 3/4 when you subtract 1/4 over. So sine equals the square root of 3 over the square root of 4, which is 2. And it would technically be plus or minus, but since we know what quadrant we're in, quadrant 4, sine is going to be negative. So then we can find tangent by doing sine over cosine. So it'd be negative square root of 3 over 2 over 1 over 2. The over 2's cancel, so we end up with just negative square root of 3. Which means cotangent is the reciprocal. So negative 1 over square root of 3, which is square root of 3 over 3, and it's negative. And then sine, by flipping that, we will find cosecant. So that's going to be negative 2 over square root of 3, which would be multiplied by square root of 3 on top and bottom. Square root of 3 over 3. So we got our other 5. There's tangent and cotangent, sine and cosecant, and cosine.